Behaving in an ethical manner should be easy, right? Especially when it comes to science. Unfortunately, research has had a checkered past when it comes to ethics. In Module 1, we'll be discussing ethical issues in biomedical research. This presentation is designed to provide an overview of the information you'll need to successfully complete the Collaborative Institutional Training Initiative, or CITI, exam. Completion of the CITI training course and exam is required for all researchers conducting federally funded human or animal research. At the end of this module, you will complete the Biomedical Responsible Conduct of Research course on the CITI website and be certified to conduct human research and analyze human data. So, is ethical behavior difficult? Well, most scientists are driven by things like an intense curiosity, a need to discover something new, and a sincere desire to solve the problems of the world, including things like what are the underlying causes of disease, and how do we solve them and how do we treat them? Unfortunately for some, and not the majority, unethical behavior can result from things like competition, the need to be first to report something. Things like fame. The more famous a scientist becomes, the more pressure he or she may experience to maintain that fame. Pressure can also come from things like the need to remain funded, which is driven by important discoveries, and even greed, because many discoveries can result in fundable or economically beneficial kinds of discovery. And unfortunately, for the very few, cruelty and or a lack of moral values can drive some very, very unethical behavior that we've observed throughout history. So ethics is defined as a set of moral principles, a theory or system of moral values. And bioethics is a specific component of general ethics, which deals with the ethical implications of biological research and applications, especially in medicine, but dealing with all research that's related to living things. A focus on bioethics is designed to ensure that all research, whether human or animal-based, is conducted in an ethical manner. Prior to the 1960s, animal research was done primarily in agricultural settings and involved, for the most part, breeding and feeding experiments in animals designed to make them agricultural products more desirable. In the 1960s, the Animal Welfare Act established the USDA, or U.S. Department of Agriculture, as the overseeing body for agricultural research. Nevertheless, at that time, the USDA refused to be the overseeing body for laboratory animals like rats and mice. And so the Office of Laboratory Animal Welfare was established specifically to provide oversight for vertebrate animals used in research. The Association for the Assessment and Accreditation of Laboratory Animal Care International, or ALAC, provides oversight for all kinds of laboratory-based animal research. Although it's voluntary for most institutions to be overseen by the ALAC, almost every credible university and clinical facility is ALAC accredited. The Institutional Animal Care and Use Committee, or IACUC, is an important body that provides oversight for all animal research studies performed in an institution. The IACUC includes a veterinarian experienced in lab animal veterinary medicine. It includes at least one animal research scientist, and it includes a community member who represents the community at large. The participation of an outside non-scientist member is extremely important for these committees because they provide a viewpoint that may not be experienced by the scientists and by the veterinarians. The central tenet of animal research is that it's only performed when human experiments are not possible or would be unethical, as in the case of things like untested medical treatments or the collection of human tissues that are not feasible, such as brains or livers. and when there's a need to minimize the environmental or genetic variation, such as in the case of the use of genetically modified animals. Animal research is acceptable if and only if suffering is minimized in all the experiments and significant benefits are expected. There are three basic guidelines for ethical animal research known as the 3 R's. The first is reduce. Whenever possible, minimize the number of animals needed in order to make a robust conclusion for the experiment. Refine. Optimize the treatment of the animals in the experiment to make the treatment the most humane possible. And replace. Whenever possible, utilize alternative models such as cell culture or statistical data to make the conclusions of the experiment. At UT Austin, the animal research ethics policies can be found at the link below. In terms of human research, early researchers working on medical treatments acknowledged that such research had the potential to do harm. Edward Jenner, Louis Pasteur, and Walter Reed all performed and tested their theories about the underlying nature of diseases on human subjects, sometimes even themselves, without any oversight or consent. As early as 1865, Claude Bernard recognized the potential moral and ethical dilemmas posed by human experimentation. He wrote, quote, "Christian morals forbid only one thing, doing ill to one's neighbor. So among the experiments that might be tried on man, those that can only harm are forbidden, those that are innocent are permissible, and those that may do good are obligatory." End quote. Ethical principles have been developed over the years that are designed to ensure that the rights of humans are protected in biomedical research and to maintain the public trust in the research enterprise. Unfortunately, atrocities committed by medical researchers in the context of discovery, curiosity, and often cruelty have repeatedly been the impetus for the creation or expansion of the oversight of ethical code in research. The Nuremberg war crimes trials prosecuted Nazi doctors who performed horrific medical experiments on human subjects without their consent and often without anesthesia during World War II. And there's an additional video in this module that explains in more detail some of the incidents that happened during the Nuremberg war crime trials. Following the trials, new rules were developed in 1947 for the permissible medical experiments in humans, which is now known as the Nuremberg Code. A central tenet of the Nuremberg Code is that all experiments should be determined if they are likely to result in injury, disability, or death to the experimental subject. The basic tenets of the Nuremberg Code include voluntary consent and the right to terminate participation at any time. There must be scientific merit, biological importance, and plausibility for any human research to take place. The benefits must outweigh the risks, and the researchers must minimize physical and mental suffering of the subjects. The study must be conducted by scientifically qualified persons, and the study must be immediately terminated if there's any threat of death or disability. Sadly, despite the atrocities observed from the Nazi doctors and the establishment of the Nuremberg Code, it did not immediately result in the cessation of unethical research. In 1966, H.K. Beecher published a report called Ethics and Clinical Research in the New England Journal of Medicine. In this report, he cited 22 medical studies published in top journals that violated the tenets of the Nuremberg Code. There were multiple cases in which subjects were not given the standard medication known to effectively treat their condition. There were multiple cases where extraneous or unnecessary surgeries were performed. And there were multiple cases in which infectious agents were given to their patients without their knowledge. What's astounding about this report is that not only was this unethical behavior going on, it was actually being published in top journals. One of the most famous of the unethical studies published in top journals was the Tuskegee study of untreated syphilis in the Negro male. This was a study that lasted 40 years in which the researchers wanted to track the natural history of syphilis using impoverished black men in Alabama. The subjects in the study were given free medical care, meals, and free burial insurance for participating in the study. Subjects were never told they had the disease, and they were never treated with effective drugs even after it had been established that penicillin could cure syphilis. In fact, the subjects were told they had, quote, bad blood. Several physicians spoke out against the study in the late 1960s, but it wasn't until reports in the press in the early 1970s that the study was finally terminated. As a consequence of Tuskegee, the National Research Act established the National Commission for the Protection of Human Subjects of Biomedical and Behavioral Research, also known as the National Commission. It required the establishment of institutional review boards at organizations receiving funds from the Public Health Services for human subjects research. The Belmont Report was based on the deliberations of the National Commission, and it was designed to provide guidelines for IRBs with three basic principles. The first is respect for all persons, which refers to respect for the autonomy of all persons and the protection of particularly vulnerable populations, including people like children, prisoners, the mentally ill, and the homeless. This component of the report also referred to informed consent and the privacy of the subjects. Beneficence. Beneficence refers to the obligation of the researchers to strive to do no harm and to maximize the benefits and minimize the risks. And justice. There should be equal distribution of benefits and risks to all persons participating in the study. This refers to the fact that randomization of the control and treatment groups should not favor one set of people over another. The Institutional Review Board is a critical component for maintaining ethical research in an institution. It provides oversight for human research, and it must consist of 5 or more people from diverse backgrounds, just like the IACUC, which oversees animal research. It must be balanced by gender, race, ethnicity, and expertise. It must include at least one scientist and at least one non-scientist, and at least one member unaffiliated with the parent institution for which it serves. No family members should be on the panel that have affiliations with the institution or any of the other members. Again, the idea is to create an oversight board in which various viewpoints can weigh the benefits and risks of the research. The Institutional Review Board approval is required for all federally funded human subjects research. It ensures appropriate study design and significant benefit of the proposed research. It ensures that there is a consent form and that the process is complete and understandable. In fact, all consent forms must be written at the level of 8th grade or less. It ensures that adequate procedures for monitoring subject safety are in place, and it ensures that subjects are clearly informed that they can withdraw at any time without penalty. In terms of human research oversight, unfortunately, some IRBs have continued to come under scrutiny, and many have not passed evaluations for ethical rigor. In fact, one of the saddest examples of a lack of IRB rigor came with the death of Jesse Gelsinger, who died of viral gene therapy in a research trial conducted at the University of Pennsylvania. Jesse suffered from a genetic defect of an enzyme produced in the liver that resulted in his inability to metabolize ammonia, which is a byproduct of protein breakdown. Prior to the study, Jesse had managed to survive on a restricted diet and special medications. He entered the trial in hopes of curing his disease forever through an adenoviral vector that would carry a corrected form of the gene. He died 4 days after entering the trial at the age of 18, having suffered a massive immune response triggered by the use of the viral vector to transport the gene into his cells. He had exhibited contraindications to participation prior to the study. There was evidence that he was not fully informed of the risks associated with the study, And there were definitely financial and non-financial conflicts of interest on the part of the researchers. The Office of Human Research Protections and the Human Research Protections Program were established following the death of Jesse Gelsinger to provide additional oversight and guidance for IRBs. The Office of Human Research Protections provides higher standards for IRB review, provides increased responsibility for the researchers, and increased requirements regarding conflict of interest. So all researchers must get human subjects training, and they all must establish an annual conflict of interest form within their institutions. There are significant penalties for noncompliance with these regulations, including the loss of federal funding for all investigators at an institution, not just the investigator violating the ethics rules. At the University of Texas, research oversight is managed by the Office of Research Support and Compliance at the following link. The Hippocratic Oath holds physician scientists to an even higher ethical obligation to do no harm. The basic tenets of the Hippocratic Oath are to maintain humility and not be ashamed to say when you don't know something, to avoid over-treatment, but to always continue to treat as long as is necessary and appropriate, to maintain the privacy of patients and to remember to treat them with respect and compassion, and to prevent disease when possible and look for a path to curing all diseases. And it's that last tenet that drives many physicians to become physician researchers. Every physician has taken this oath, meaning that what they say is given even more weight and more credibility than that of the average person, which gives them a much bigger responsibility than most. Research misconduct is defined as the distortion of scientific knowledge through things like fabrication or reporting of non-existent data, or falsification, which can include selectively reporting data or deliberately altering existing data. Misconduct can also be associated with misleading the scientific community through things like misrepresentation of authorship, plagiarism, guests or ghost authors, duplicate publications, and abuse or neglect of the peer review system. Fortunately, reports of scientific misconduct are relatively rare. Unfortunately, there have been some significant cases reported for falsification and fabrication. Eric Pullman was a famous researcher who was known for his work on aging, obesity, and menopause. A technician in his laboratory worried about the way in which Dr. Pullman collected and managed his data. Dr. Pullman was ultimately found guilty of falsifying data for 17 grants from the National Institutes of Health and 10 major publications, of which all have been retracted. Dr. Pullman lied repeatedly under oath and sought to discredit the technician who had reported him. As a result, he was fined $180,000 and sentenced to 1 year and 1 day in prison. Because of this flagrant falsification and denial, his is only the second case of scientific fraud to result in a prison sentence. The case of Andrew Wakefield is one that has had continuing fallout. Andrew Wakefield was the lead author on the Lancet paper that first reported the link between the MMR vaccine and autism. As a consequence of this paper, many parents began refusing the vaccine in order to protect their children from perceived increased risk of autism. After a 2-year investigation, it was concluded that Wakefield had grossly misrepresented or falsified patient data reported in this paper. It was also revealed that Wakefield had accepted more than $674,000 from lawyers who wanted a medical study to help support a lawsuit against the vaccine manufacturers. Lancet ultimately retracted the paper, and Wakefield was barred from the UK Medical Registry. In 2014, a major meta-analysis that included more than 1.2 million children decisively concluded that there is no relationship between the MMR vaccine and autism. Nevertheless, the myth still persists in the minds of many potential parents that vaccines increase risk for autism. Thus, fabrication and unethical content can have lasting effects. Dr. James Wilson is a good example of how pressure and conflicts of interest can lead to unethical behavior. Dr. Wilson was the principal investigator of the clinical trials of viral gene therapy associated with the death of Jesse Gelsinger, who we heard about earlier. Jesse was an 18-year-old affected with a rare genetic disorder of urea metabolism called ornithine transcarbamylase deficiency syndrome, or OTC. In fact, Jesse had a mild form of the disease that was treatable with diet and with medication, but both Jesse and his parents were hoping that the viral gene therapy would replace the defective form of his gene with a corrected one. Unfortunately, Dr. Wilson and his colleagues ignored or even suppressed evidence of significant side effects that they had observed in both rats and non-human primates in the laboratory. They didn't report these risks or side effects to the patient or his parents. Despite the fact that Jesse showed up to the clinic that day with elevated blood ammonia and signs of liver malfunction, they proceeded with the trial anyway. 4 days later, he died of multiple organ failure and brain death. In the investigation following the death of Jesse Gelsinger, it was reported that Dr. Wilson had a major financial interest in Genova, the company developing the therapy, representing a significant conflict of interest. As a consequence, Dr. Wilson was banned from participating in clinical trial research for 5 years. Nevertheless, he is currently a professor at the University of Pennsylvania and the editor of the Gene Therapy Journal. He lectures now on the importance of exercising caution as a clinical scientist. Sadly, there have been additional cases of scientific falsification and fabrication, but they almost always get caught. Most researchers are honest, hard-working people. For every report of scientific misconduct, there are thousands of scientists working really, really hard to do important, impactful work. So even if the behavior in the laboratory or the research setting is ethical, some elements of unethical behavior can be introduced at the level of authorship and publication. Authorship can be a contentious issue if not discussed prior to publication. Authorship order should be discussed prior to the creation of a manuscript, and it might need to be revised as the editing and revision process goes forward. Trainees, including people like junior faculty, graduate students, and technical support personnel, sometimes have unreasonable expectations regarding authorship, which is not always guaranteed, regardless of how much they need the credit to advance their career. Ghost authors include technical writers that are not involved in the research themselves. Guest authorship or gift authorship represents listing an author that has not contributed substantially to the work. It can be given voluntarily. For example, I can give authorship to a colleague of mine, or involuntarily, my chair or boss may require me to put them on papers. Publication issues can also include publishing the least publishable unit, which refers to dividing a research project into as many papers as possible. This can dilute both the impact and the message of the research. Duplicate publications of the same exact research in journals can also produce bias. The authorship standards recommended by the International Committee of Medical Journal Editors state that authorship should be based on the following. You should have contributed significantly to the study conception or design, and/or have contributed significantly to the acquisition and/or analysis of the data. In addition, you should have contributed to the drafting, editing, and revising of the manuscript. You should have approved the final version of the manuscript, and you should have agreed to be held responsible and accountable for the content of the manuscript in order to earn a journal article authorship. If you feel you did not contribute substantially to a manuscript and you are offered authorship, you should decline, and you should request acknowledgement only if that's appropriate. Plagiarism, as you all know, is the intentional or unintentional use of the work of others without proper credit. Plagiarism can include presenting someone else's work as your own. That's pretty flagrant plagiarism. Failing to attribute a quote to its author, and often that is inadvertent. Intentionally providing an incorrect citation, so rewording an author's words in a way that changes the meaning, or using ideas from other sources as the majority of your proposed work. Moving or changing a few words is not paraphrasing, and when in doubt, you should always provide a citation. Some ethical issues related to data itself include validity and reliability. As a researcher, it's your responsibility to ensure that the measurement instruments you use measure what they're supposed to measure. That could be instruments that measure physical measures like a height and weight, or it could be questionnaires, or it even could be laboratory assays. It's also important that you ensure that the measures are repeatable and give the same results over time. In terms of confidentiality, there is legislation that protects the confidentiality of specific kinds of information. Healthcare records are protected by the Health Insurance Portability and Accountability Act, or HIPAA. And now when you go to your doctor, you're given that HIPAA form to sign, acknowledging that your medical health records are protected. Student records are protected by the Family Education Rights and Privacy Act, or FERPA. Data ownership is a key issue in which you need to ensure that you have the right to share data collaboratively. And as an owner of data, you have a responsibility to protect the confidentiality and the integrity of data, no matter who is working with it. All members of a research team are obligated to comply with these regulations. The use of big data sets have their own particular issues. Big data can refer to high-level genomic data, it can refer to gene expression data, it can refer to comprehensive phenotype data in large data sets, and in fact many large data sets are now publicly available. For example, the UK Biobank consists of about 500,000 people that have been extensively phenotyped and genotyped and characterized in a number of ways. And the use of such data sets requires special permission, including a detailed application outlining exactly how you want to use the data and for what purpose. Just because you're given the use of a data set doesn't mean you own the data set or have the right to share it. In fact, data generated through government-funded research, like an NIH grant, is actually officially owned by the institution to which the grant was awarded, although the researchers are normally accepted as the responsible stewards of the data. The research team may also possess some intellectual property rights if some important discoveries are made, and that depends on the type of the discovery. In terms of data that you own, if you're going to share it, you have to be very careful that you de-identify the data to protect the confidentiality of the subjects in the study. You must remove names and physical or email addresses, all elements of dates except the year. You must remove telephone and fax numbers, device identifiers and serial numbers, web URLs, internet protocol addresses, any kind of personal identifying numbers, any kind of biometric data that you might have collected, including finger and voice prints, and of course full face photographs or comparable images. Once you've removed all of these types of data, you have a data set that is now de-identified and shareable with others. All researchers who perform human subjects research, including analysis of human data, must complete human subjects training. After watching or reading the lessons presented in this module, you can then complete the CITI certification and training. To complete the required training, go to the city website at the link below. After clicking on the Login button in the upper right-hand corner of the very first screen, then click on the link to log in through My Institution. Log in through the University of Texas at Austin link, and you'll be given a list of courses to complete that you can complete. Complete the Biomedical Responsible Conduct of Research Course 1. Download the completion report for your first lab book assignment, and you are now a human researcher.